Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azia Iman Biasnan. My metric number is S74434. So today in this video, I will be presenting about the Trochophore larvae. So for the introduction is Trochophore larvae are free swimming and planktonic larval stage found in several marine invertebrates. They play an important role in the development and dispersal of these organisms before they transform into juveniles and eventually adults. The Trochophore larvae develop from a fertilized egg and later transform into a juvenile from through metamorphosis, and it is considered an important development stage in many marine organisms. So, what type of aquatic organism possess a Trochophore larvae? There's four types that I can give in this video. So the first one is oyster, the second one is mussel, and then the scallop, and lastly is clams. So I will explain to you about the position of Trochophore in the life cycle. So the position of the Trochophore in the life cycle will begin with a fertilized egg, which develop into an embryo. After hatching, the organism enters the Trochophore stage. During this period, the larva swim freely in the water column, feeds on microscopic particles, and grows rapidly. As the development continues, the trochophore transform into a more advanced larvae stage, such as villiger larvae in mollusks or a segmented larvae in annelid. It then undergoes metamorphosis into a juvenile and finally becomes an adult. So lastly, I will explain about the morphological characteristic of a Trochophore larvae. The first top of the body is the apical tuft, which consists of sensory cilia that helps the larvae detect its environment. Below this is the apical organ, which function as a sensory center. The next one is around the middle of the body is the prototroch, a prominent band of cilia that is responsible for swimming and capturing food particles. This is one of the most important structure in the larvae. The next one is the mouth, allows food to enter the digestive system where it passes through the stomach and intestine for digestion and nutrition absorption. The next one is near the posterior end is the telotroch, another ciliary band that helps with movement and balance. Finally, waste is expelled through the anus. Overall, the Trochophore larvae has a transparent body, bilateral symmetry, and specialized ciliary band that enable efficient swimming and feeding in the planktonic environment. That's all from me. Thank you.
Why is the trochophore larvae is important is because the larva development, trochophore larvae is the first free swimming larvae after gastrulation that develops cilia and helps in movement and feeding. For species Limbatus, the stage appear a bit about 9 hours after fertilization, and the transition towards veliger stage begins and organs continue to develop. The D-shaped larvae that are commonly seen were observed after 26 hours after fertilization. In larval survival, their successful development is important, and this study shows that the microalgal diets influence the larval growth and survival. Their role in aquaculture production are the foundation of food source and marine species and provide a larvae for large-scale aquaculture cultivation that enables dispersal of the species across marine habitats, and the understanding the larva stage helps improve hatchery management.
Hello, my name is Fizul. My metric number is 74596. Today I want to present about importance of plankton for trochophore larvae. Firstly, types of plankton associated with larva feeding. Microalgae phytoplankton are the primary live feed used in hatcheries because they provide essential nutrients required for larval development. The example for plankton species is like Asocrasis species, which is the important is rich in DHA and essential fatty acid. They promote larval growth and survival. Next, Stegosaurus species, high nutritional value and commonly used in mollusc hatcheries. Next is Tetraselmis species, which is provides nutrients, lipid, vitamin, and mineral. Next, and the last is Nanochloropsis species, which is rich source of EPA and highly digestible for larvae. The important thing is no single phytoplankton species can provide all nutritional requirements. Therefore, mixed microalgae cultures are commonly used in hatcheries to improve larval growth and survival. Okay, so the next slide is number 2, which is nutritional value of plankton. The plankton provides essential nutrients needed during the early developmental stages. Key nutrients for Trochophore larvae is protein for tissue formation and growth, lipids as an energy source, essential fatty acid, DHA and EPA for cell membrane development, vitamin and mineral for metabolic processes, and pigments and antioxidants that improve larval health. The importance of plankton is support rapid cell division, enhances immune function, improves metamorphosis success, and the last one is increases larval survival rate. Okay, here we go for the slide number 3 that I did, which is feeding behavior of Trochophore larvae. Trochophore larvae are generally planktotrophic and depend on suspended food particles in the water column. The feed mechanism, which is cilia surrounding the larva body, create water currents. Food particles are captured from the surrounding water. Plankton cells are transported towards the mouth. Digestion provides energy for growth and development. Why feeding is important? The important is for supplies energy for swimming activity, supports organ development, facilitates transition to the follicle stage, and the last one is reduces starvation related mortality. The last slide from me, which is number 4, relationship between food availability and larval survival. Food availability directly influences larval performance. When food is sufficient, faster growth, better development, higher survival rate, and successful metamorphosis. When food is insufficient, the Trochophore larvae, slow growth, delayed development, increased stress, higher mortality. So the conclusion is high plankton availability for better nutrition for faster growth, and faster growth is for higher survival and successful hatchery production. That's
Hi Doctor, I'm Yuvraj Anankravi and my metric number is S74289. So today I'm going to present about the part D, which is aquaculture applications. So let's explore what's the understanding of life stages of, and basically the example of Spondylus limbatus as into practical farming strategies. So first we look at the settlement and substrate optimization. Unlike many other bivalves that rely on temporal missile threads, it basically it exhibits post-larval behavior, which means it permanently cements itself into a hard substrates. So what it does is it can be designed into a specialized settlement plates or utilized into crushed spondylus shell fragments, which is similar to what was done in the study monitoring phase. So next I would like to talk about the post-settlement grow and juvenile management. So once the settlement occurs, it should be adapted into a post-settlement grow out and juvenile management parameters. So during the critical 2 to 3 month post-larval crawling phase, traditional aggressive bivalve handling methods such as mesh sieving and high pressure washing must be strictly avoided or minimized. The larvae have incredibly delicate developing shells and feet that are easily damaged. To mitigate this risk, our substrate strategy should involve incorporating crushed spondylic shell fragments or similar calcium carbonate rich hard substrate directly into the setting tanks. So we took the we took this species as an example for this application, so that people know about this species in a good way. So the third one would be integrated multi-trophic aquaculture systems. So next, what the species does is it shows an incredible potential when integrated into IMTA. So specifically for shrimp and fish farm effluent bioremediation. By replacing the species which is S. libitus, long lines or bottom cages downstream from intensive marine finfish or shrimp operation, we can utilize the farm waste. The bivalves naturally feed on organic particulate matter, uneaten feed and suspended microalgae. It can serve a dual purpose. Mainly is to clean the farm discharge water, acting as a bioremediator, and provides a zero input in a high value secondary harvest for the farm. Next, I would like to go about the strategies to improve the larvae survival. So it basically needs nutritional phasing for the planktons, which is much more recommended. It recommended as harvesting cultured microalgae strictly during their exponential growth phase. This is when the nutritional profiles are at their absolute peak, giving the larvae the best possible fuel. Next will be the probiotic use, which is we can integrate specific beneficial bacteria into the culture. This helps outcompete opportunistic pathogen and stabilizes both the larvae's delicate gut microbiome and their overall rearing environment. That's it from me. Thank you.
So based on this journal, several important findings were obtained regarding to early life cycle of Spondylus limbatus in aquaculture production. First, the study successfully described the complete larva development stage starting from egg, Trochophore, D-larvae, veliger, pediveliger, post-larvae until juvenile stage. The study also found that the best larval growth was achieved during a mixed microalgae diet of Chaetoceros gracilis and Isocrasis galbana at a 3:1 ratio. So secondly, aquaculture practitioners should understand the Trochophore stage because it is an important early development stage that determines whether larvae can continue developing normally. This stage very sensitive to environmental change and especially water quality and temperature. Thirdly, plankton culture is very important because microalgae serve as the main food source for larvae and provide essential nutrients such as EPA and DHA, which are important for growth and survival. So finally, future research should focus on improving hatchery water treatment system and controlling bacterial contamination in culture tanks, as these factors can help increase larval survival and improve aquaculture production efficiency. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Muhammad Afiq bin Sa, and I will present about the conclusion. To conclude, the Trochophore stage is a critical early development stage for many marine invertebrates. At this stage, larvae rely on plankton, especially microalgae, for nutritional growth and survival. Understanding their feeding requirement and environmental health needs help improve hatchery success and larva survival rates. With a proper plankton culture and good water quality management and modern aquaculture technology, we can ensure sustainable seafood production and support future growth of the aquaculture industry. Thank you for your attention.